All right, so today we are looking at lesson 8-5, trigonometry application. Today's learning intention is I will learn how to use trigonometry in story problems. Go ahead and get that down, and go ahead and make sure all your perfect squares are down, 1 through 15. All right, number 1, when the sun is up 32 degrees from the horizon, the wall of a store casts a shadow of 25 meters long. How high is the wall? Okay, so what we're saying is we have the sun up here and it's shining down, and as it hits this wall, it's casting a shadow. Remember, shadows are on the ground, okay? And it's up 32 degrees, okay? So we have our angle here. It's wanting to know how high is the wall. The wall right here, this is what we're looking for, okay? And then remember, the shadow of the wall is right here, okay? And this is 25 meters long. So now we're solving for x. So we ask ourselves, are we looking for a missing angle or a missing side? Side, because we have an angle. Our variable is on the side. Okay, so we're going to use regular, sine, cosine, or tangent. And I'm going to go ahead and write my SOHCAHTOA up here so I have it. Okay? And so I'm going to ask myself, this is where my right angle is. Do I have a hypotenuse? Is there a hypotenuse? No. So I know right away I'm dealing with tangent. Tangent is opposite over adjacent. So to set this up, I'm going to say tangent. My angle measure is 32 degrees equals my opposite. My opposite of 32 degrees is what's across, what's not touching it, which is x, over my adjacent, which is what is touching it, which is 25. Okay, so we need to get rid of this denominator, so I can times by 25. If I do it to this side, I have to do it to this side. And that's what allows these to cancel. So I'm left with 25 tangent 32 equals x. Is my x by himself? It is, yeah. So that's all I need to do is put this in my calculator. 25 tangent 32. Okay, very good. So 15, I'm just going to put 0.6. And then, is there a unit of measurement I need to put with this? Meters, very good. So the height of the wall is 15.6 meters tall, right? Okay, number 2. From eye level, so my eye is right here, off the ground, 5 feet off the ground. So this person's eye is 5 feet off the ground. So that means this flagpole over here is, at eye level, is 5 feet. The ground is here, but the person's eyes start here, okay? So from eye level, 5 feet off the ground and 20 feet away from a flagpole. So he's 20 feet away from the pole. So it would make sense to say this. A person has to look up at a 40-degree angle. Angle of elevation to see the top of the pole. How high is the pole? So what we're wanting to know is how high is this whole pole. So this whole pole from top to bottom. So what can we do? Can we go ahead and find this height right here? This height right here, and then add this part to it to find the whole height? Okay, so to find this x here, we would set this up. First of all, is there a hypotenuse? No. We know we're dealing with what? Tangent. Good. Opposite over adjacent. Okay? So if this is my angle measure, what is opposite of this? X. What is touching it? What is adjacent to it? 20 feet. Very good. Okay, so we are finding a side. So are we doing regular tangent or inverse tangent? Regular. Very good. So I would set this up. Tangent 40 degrees equals x over 20. Solving for x, you get rid of the denominator. Got to do it to both sides, though. So I'm left with 20 tangent 40 equals x. Is my x by himself? He is. So I just put this in my calculator. And I'm going to put approximately, okay, 16.8. What did we say we needed to do? That's this height here. Add the 5. Very good. So technically, x 21.8. We'll do 8. Keep the 8. Yep. 8 what? Feet. Okay. Do I need to go back? Everybody get that? Okay. From the top of a building, you look down at an object on the ground. If your eyes are 55 feet above the ground and the angle of sight, called the angle of depression, is 50 degrees below the horizontal, how far is the object from you? Okay, so what we're saying is this is our eye level, and our eye level is 55 feet off the ground. So they already have this here for us. Okay, it says that the angle of depression is 50 degrees below the horizontal. So it's saying if I'm looking out, it's going to be 50 degrees. Okay, right here. And then we learned something last chapter about if I have a parallel line here and here, and I can make this Z like this, what can I say about this angle here if I know this is 50 degrees? We talked about alternate interior angles, so this is 50 degrees. Okay? It wants to know how far the object is from you. So this is the object. The object would be here because you're looking down. You're looking down at an object. How far is the object? So it wants to know how far from here to here. So this is where my x goes, my variable. Okay? So first of all, my right angle is here. Do I have a hypotenuse? Yes, I do. Okay? So if this is my angle right here, and I have a hypotenuse, the other number given to me is this. So is it touching this angle or not touching? Not touching, so that is opposite. So I'm dealing with what? Sine. Very good. Okay? Now, am I finding an angle or a side? A side, so it's a regular sine. And I'm going to go ahead and write my opposite. My opposite was 55. My hypotenuse was x. So I'm looking for a side, so this is sine. My angle degree is 50 equals 55 over x. Okay? Solving for x, getting rid of the denominator, I got to do it to both sides. This leaves me with x sine 50. These cancel, so it equals 55. Now, is my x by himself this time? No. So how do I get x by himself?
You divide sine 50 from each side.
Very good. I'm going to divide by sine 50 to both sides. That is what allows these to cancel, and I'm left with x is approximately, this is what you put in your calculator, 55 divided by sine 50. And what do we get? Good, 71.8. And what's my unit of measurement? Feet. So you are around 71.8 feet from the object. Okay? All right, number 4. From a point at the foot of a hill, so I have this point at the foot of the hill, the angle of elevation is 15 degrees. Okay? The distance from the foot of the hill to the top of the hill is 150 meters. So from the foot to the top, very top of the hill. It says that this is 150 meters. Okay? Find the height of the hill. So the height is going to be the top to the bottom. Okay? So this is my right angle. It wants to know what? The height, which is right here. Okay? So right away, do I have a hypotenuse?
Yes.
I do. And if this is my angle, and this is my hypotenuse, the other one I'm dealing with is over here. Is it touching or not touching, this angle? Not touching. Good. So this is opposite. So I'm dealing with sine. Very good. Okay, so I'm going to go ahead and my opposite was x over my hypotenuse of 150. Okay, so am I looking for a side or an angle this time? A side. So it's going to be regular sine. So I set this up by saying sine 15 equals my x over 150. Okay, getting rid of that denominator. I got to do it to both sides. And those cancel, so I'm left with 150 sine 15 equals x. Is my x by himself?
Yes.
Yes. So I can just put it like this in my calculator. 38.8 meters, right?
Yes.
Very good. So that is the height. All right, now we're going to draw our own pictures, okay? So number 5, a 30-foot ladder leans against the top of a building, making a 72-degree angle with the ground. How tall is the building? Okay, so I'm going to draw myself a building here. So I'm going to say this is the side of my building, okay? And I'm going to have a ladder leaning against it. And okay, so this is my building, and this is my ladder. It says my ladder is 30 feet. And it says it's making a 72-degree angle with the ground. So this is the ground, so here's 72 degrees. It wants to know how tall this building is. Okay, so I have a right angle here. So do I have a hypotenuse? Yes, I do. So hypotenuse. Okay, and if this is my angle measure right here, and this is my hypotenuse, this is the other guy. Is it touching or not touching? So it is across from it. It is opposite. So we're dealing with what? Very good. Okay. So my opposite was x over my hypotenuse, which was 30. Okay. And am I finding a side or an angle?
Side.
Side. So that's regular sine. Okay. So I'm going to have sine 72 equals my x over 30. Getting rid of the denominator, I'm going to divide by 30. And that allows these to cancel, and that leaves me with 30 sine 72 equals x. Is x by himself? Yep, so I can just put that in my calculator.
28.5.
Good, 28.5 what? Feet? So the building is approximately 28.5 feet tall. Okay? All right. One more, guys. Number 6. A plane takes off. Okay, so I'm gonna have a little plane here. You like that?
Yeah.
Okay, so a plane takes off at a, I'm going to start here on the ground, at a 24-degree angle. Okay, here's my ground. Here's the runway. Here's the ground. He takes off at a 24-degree angle. How far has the plane traveled in a horizontal distance after traveling 3 miles? So he's going to travel. Here he is traveling. And he's going to go 3 miles. Okay. How high in feet? So here he is in feet. And how high? So we're looking for how high is this, right? Okay. How how high in feet is the plane from the ground currently? Okay, so we actually have two different questions. So we have how far has the plane traveled in a horizontal distance? Okay, and then we have another one that says how high in feet is the plane from the ground currently? So we're going to have two different ones. We're going to have how high and this down here. So I put two different variables, okay? So we need to solve one x and another one y, okay? So how far has the plane traveled in a horizontal distance? This is my horizontal distance down here. So to set this up, we're not paying attention to this guy right now, okay? So do I have a hypotenuse? Okay, and I want to solve for y. So is this one opposite or adjacent to this angle? Adjacent. So to find this question, we're dealing with cosine. Okay, so to set this up, we're going to have cosine 24 equals my adjacent, which is y, over 3. Okay, so solving. So my 3 cosine 24 equals y. Is my y by himself? Yep. So put that in the calculator, and I get y is approximately 2.7. 2.7 what? Miles. Okay. Now let's look at the next one. Now we want to solve for x, because this question is how high. Okay. So do I have a hypotenuse? Yep. And now I'm looking at this guy in according with my angle. So I'm not paying attention to this one. Is this one touching or not? Not. So this is opposite. Dealing with what? Sine. Okay. Looking for a side, so it's regular sine. And I'm going to go ahead and write my opposite. My opposite is x over my hypotenuse, which is 3. Okay. So I would set this up sine 24 equals x over 3. Getting rid of the denominator allows these to cancel, so I have 3 sine 24 equals x. Is x by himself? Good. And so my answer is x is approximately 1.2 miles. Okay. What do we notice it wants right here? Feet. Okay. So how many, does anybody know how many feet are in a mile? 5,280. Very good. There's 5,280 feet in a mile. So you would just take this times that, and you would get it in feet. And anybody got it for me? I don't have a calculator. Should be like 6,000 something. 6,000 what? 6,336 feet. Now I have it in miles and feet. So if you want both, you can have it in both. Okay.